Hello, this is Team 3. This week we will talk about the overall construction process of the building. The top of Lotte Tower located in Jamsil, Seoul, it was constructed using the diagram method. Let's compare the foundation part of Lotte Tower and St. Mary X. St. Mary X foundation capacity of 170,000 tons and the number of files used is 333. It can support a design load of 351 tons per file. The foundation capacity of Lotte Tower is 750,000 tons and the number of files used is 108. It can support a design load of 60,944 tons per file. Each file has a diameter of about 750 mm and an average length of 27 m. Combined, the total length of the file amounts to a whopping 9 km. They can carry a total design of 170,000 tons. To create a solid foundation considering the clay land of London, all files and file caps were all poured in just one day. This allowed them to overcome field constraints and create a single file solid foundation. London is on the soft ground downstream of the river, mainly composed of moist soil and acidic soil. 333 of these files were constructed to strengthen the ground. It's a deep-rooted skyscraper, like a tree that's rooted deep in the ground. Construction company Skanska poured 1,750 cubic meters of concrete into 32-meter diameter central file cap in a 12-hour operation, and it was needed a concrete to load about 280 trucks, needed up to 25 vehicles per hour arriving at the site from 3 development plants. The St. Mary's building consists of three main structures: core, radial beam, diagrid. A unique sequential process was applied to the steel frame construction of the Gherkin project. First, the core part constructed 6 floors ahead, and the A-shaped frame of this floor was fastened to this core part. The stable core structure ensured initial robustness so the A-shaped frame could be precisely combined. Since then, the overall height of the building has gradually increased by repeatedly installing the A-shaped frame band of 2 stories high. St. Mary's structure system consists of two main elements, core and diagrid. Core and diagrid are structurally complementary. The nodes are connected with radial beams, which can transfer vertical and horizontal loads to the core. The entire diagrid forms a single rigid frame. Therefore, the core prevents deformation of the diagrid structure, and the diagrid also redistributes the load acting on the core.
After the core part of the six-story height is constructed first, the construction of the diagrid starts. Assembling the A-frame, which consists one node and two tubes, it is erected perpendicular to the ground using a crane. Repeat the same process to install a total of 18 A-frames that make up two floors. After a total A-frame are erected, the node part of the diagrid is connected to the core using a radial beam. At this time, it has the effect of secondary distribution of the load applied to the core by the diagrid through the radial beam. The construction of the two-story diagrid is completed by connecting the node and the horizontal beam. For the construction of an empty story in the middle, a radial beam is used in the middle of the diagonal members to connect to the core. Finally, the diagrid construction of a two-story triangular module is completed. As the steel structure goes up, repeat the process of installing A-frames, connecting radial beams, and connecting horizontal beams process allowed to be installed upward. The diameter of the diagonal members change as the diagrid ascend to the high rise. At the low floor, a lot of structural load must be shared. So the diameter of the lower floor tube is about 500 millimeter. However, because the A-frame on the high-rise received less structural load, it is smaller diameter of about 205 millimeter. For the successful construction of a diagrid structure, a very small tolerance are required. Among these, precise design of the node is required. So, which method were used to minimize tolerance? First, determine the shape of the diagrid module in the building, and then determine the number of nodes on each floor according to each module type and the height of the building. Finally, select the optimal angle within the range of possible between each node. The St. Mary X building was designed as the two-story triangle module. The nodes were placed in triangular shape according to the height of the two floors. This is an important factor in determining the total number of nodes. The reason why the node used a triangular module designed based on the height of the two floors is as follows. Each floor has a plane that rotates by 5 degrees. As a result, the angle of the two-story diagrid is set to a total of 10 degrees. Therefore, the building with a circular plane consists of 36 radial beams, from the core to the diagrid, each containing 18 nodes with a height of the two floors. As a result, a total of 360 nodes were used in the St. Mary X building, which has a height of 40 floors. The height of each floor is the same, but since the number of nodes per floor is fixed, so the angle of the node changes as it goes up. Therefore, the St. Mary X building applied the variable angle node method, where the angles of the node changes according to the floor area. As the high part node has a small floor area, the angle of the node is placed the largest, about 77 degrees. In contrast, the low part node has a large floor area, so the angle of the node is placed as small as 60 degrees.
The diagrid node of the Gokuen building was constructed in a five-phase transition type consisting of a combination of three integrally welded plates and bolts using hollow section. The node includes an hollow section diagonal member, a ring beam horizontal member, and a radial beam integrally connected to the core, which evenly distributes the load on each floor to enhance the stability of the entire building. In order to minimize errors that may occur during the construction process, CNC milling and slot-hole bolt bonding are performed. When factory-made diagrid members arrive at the site, they are moved to the installation location using a tower crane. After the members are placed in the correct location, temporary tightening is performed to maintain adhesion and spacing between members to reduce construction errors. Accuracy is very important in the construction of a diagrid. Therefore, the construction is carried out by adjusting errors such as precise measurement of the angle, length, and connection position of the members using equipment such as laser subbing machines and total stations. Finally, when our temporary work is completed, tighten the high-strength bolts with the specified torque to finish. In the next time, I will explain the quaternary details and the internal HVAC system in detail. Thank you.